Yeah, everyone, welcome back to Health channel. I hope everyone doing well, good and safe. So, in last networking days, we're going to talk about border gateway protocol, and this is the last topic for this networking, and it is very useful protocol, not for this on-prem or not from the network perspective. It is very useful for the cloud as well while doing the connectivity. It is a very important to check the BGP session. So that is very interesting and very important topic for the networking, that is border gateway protocol. Here some point, which point will be going to be learn here, that is autonomous system, types of the BGP, basic features, loop prevention, and when will be going to be used and when not to use the BGP. So that is the overall concept, or that is the overall agenda for this session. Okay, so let's start. Okay, what is the BGP's feature first? It is a open standard that you can run into the Cisco and non-Cisco devices as well. So any device can be used. It is a open standard and it is a external gateway protocol. That means mainly it is used for this ISP because they need to be maintained multiple is, so that's what they need exterior. So the feature is exterior gateway. That means if you have the multiple AS number and you want to be connected to each other, so that's what they need BGP. They are using the BGP. Here, designed for the inter-AS domain routing. That's for, we can say that's for the, again, ISP provider. Let's take example. If you have this organization and multiple AS is connected, and let's take example. If you want to be connected to the google.com something, then your request is going to be that ISP1. Let's take example, this is ISP1, this is ISP2, and they are interconnected to each other. Now let's take example, if you are requesting to the google.com, first request is going to be whatever your internal setup you have, then it is going to be ISP. Then ISP is connected the multiple AS. That means they should know about the routing where the server of the google.com, then they will get the acknowledge from this google.com, then the user will get the access of the google.com. So that means it is very useful for your internet, and they should have to know about the connection of the multiple layers, and they can get the knowledge of they can get the information in their routing into the another server or where it's hosted. That's what designed for the inter-AS domain routing. This is very, we can use for the inter network like internet. It is used for the classless. That means carrying the subnet mask along with the network. This is a support for the LSM, LSM, SADA, ATO, manual summary. That means fixed length subnet mask, variable length subnet mask, class internet domain routing, as well as ATO and manual summary as well. And if in case if something happen into the network or within a AS or outside the OS, the updates are incremental and trigger immediately basis. So there are using the multiple BGP message as well. We'll see into the next slide. And it is supported for the path vector protocol and AD value, that 20 for this external and 200 for the internal. So that is the things. Let's take example. What is the path vector? Okay, I have created this diagram. So path vector in the sense, let's take example. This is my router ID and this is my path is going to be to reach the this 6510. Now, when when I'll be sending the information this router to this AS number or whatever the inside is what are the router is present. If I am sending the information, they will carry what they will carry. They will carry what is the AS number, that is 65400, and what is the network 10.1.1.0. In next router or next years, if they are transferring to the 6520, then they will be taking information. It is coming from which 65300 and as well as 6400, because this is advertising network and the network information is 10.1.1. Similar way, when it is transferring to the 1, then there will be 6500 first, second 300, 65300, and last 100, sorry, 400, and that is the what network they are using. That means they are following the path with along with the information which is the information is coming and which router ID they have. So that is concept of the path vector protocol. And if in case it is going to be back loop or something, we'll see in the next slide. But the path vector, it is how they are carrying information. The information, if they are sending to the 65400 to 65030, then if they are transferring to this next router or autonomous number, they are carrying 65300, 6.400 along with the network information. And if they are going to be this AS100, then they will know about, okay, first it is coming from the 400, second is coming from the 300, and third it's coming from the 200, and the network information they have. So it is follow the path mechanism. That's what it is comes under the, it is called as the path vector protocol to the for the BGP. Okay, so one more feature is there. It send updates manually define neighbor as a unicast. That means if you have the router 1, router 2, and let's take example, if you are using the EHRP, if you are using the EHRP and you have mentioned the EHRP autonomous number 10, EHRP autonomous number 10, and if you have in like entering the router EHRP and network information, then they will start the exchanging information without doing anything, right? But when it comes under the BGP, you need to be mentioned for this one. In this port, you need to be mentioned neighbor, this port, and this neighbor to the this port. That means manual configuration is there, and you should have to define why this is for this next neighbor and this what they have called for the BGP. It is manual configuration. We need to be configure neighbor as a manual, and it is application layer, and it is using the port number TCP 179 while doing exchange of the routes. So the main thing is that if you are using any interior gateway protocol like RIP, OSPF, PHRP, they are, you don't need to be do anything. That is, they will be going to exchange route. Once you enter the network information, they will be going to be maintain the neighborship as easily. But while in BGP, if you want to be create a neighborship, it should be manual. That means this port you need to be mentioned what are the IP of this next, and this port it should be mentioned how it is a neighbor. And if you have the another router as well, then you should have configured the neighbor multiple times. So that is the BGP, and that is the one of the toughest tab, the routes we need to be configured manually. Sorry, not a routes, the neighborship. Okay. Now let's take example. We'll focus on this AS. We already discussed into the AHRP what is AS number and how it is defined. This, let's take example. If you have one of the AS and inside there are multiple router is there and they are connected to each other, the multiple pathway. So We can say that it is a single technical administrator, that is AS, that we can say that inside the AS there are multiple routers interconnected, that is we already seen the mesh topology. And if in like if you want to connect the different AS, we'll see into the external gateway protocol as well, that is external BGP as well. But here is in AS we need to be focused on here only what is the router and how many router inside the AS, that is the AS. There are two types, that is public AS, that is globally unique and unique into the organization. You can see the number, that is 1264511 numbers. You can use the public AS, and for private you can use the 64512 to the up to 653035. But let's take, there are two are reserves because for this starting and ending, and some for reserve for this documentation use, so that you cannot use this type of the BGP AS number. Okay. Now, let's take example that next one is internal gateway protocol and exterior gateway protocol. There are the two types of the BGP. Interior gateway protocol is the example of the RIF, IGRP, EHRP, OSPF. That means, let's take example, you have the organization of ABC and the router is present into the different location or same location, it doesn't matter, but they are belongs to the same autonomous number. That means they are interconnected to the internally, that means internal gateway protocol, that trip OSP PHRP you can use it. But what will happen if you have the different organization? Let's take example, this is the XYZ organization, and you want to be communicate ABC to the XYZ, then how it's possible? You can use BGP and it is very useful. That means IGP operates within a AS number, that means AS 100. But if we are talking about EGP, it will operate as a different, that is AS 100, AS 200, or here one more AS number is there also, that is possible to the connection. So that is the types of the BGP for interior gateway protocol and external gateway protocol. And we already seen that they are using the which ED value 20 and 200, internal and external. Now the one of the main features will get loop prevention mechanism. Why it's needed? If we are talking about the switching, we have seen that which protocol, spanning tree protocol, they are avoiding loop. Similar way in BGP, that means let's take example AS200. What is the network? 10.1.1.0. When it passes to the AS100, right? Then it's going to be 100. But the information is it's coming from the where? 200 AS number and the network information as it is. When it's passed to the 300, what will happen? It's came from the 100, AS number 100 and 200 as well, right? Now, what is happening when it comes to 300? It is going, if 300 is passing to the 200, it is not accepting. That's what it is cross means. If the information is passing through AS 200 to the 100, same information that 100 to 200, and then it's when it comes under the 300 to 200, because it's creating the loop, it is not accepting because the information routing information already exchanged, and that's what this router or AS is not going to be accept this one. So in if you have the very complexity of network, very huge network, then it is not possibility of these loop things. That is the background of this one, and it is very easy. to understand, it doesn't matter how many AS number, you can add multiple AS as well, but the loop prevention, that means while transferring the one AS to the another AS, one router to another AS, they will be using what are the router ID, what are the autonomous number they are coming, and the information they will be going while going to be exchanged to another or next one, they are going to be store this one. And if it is going to be 300 to 100, they can see, okay, I have already router information 10.1.1.0, so I'll be not going to accept. So that is the main, that is path vector as well as loop prevention mechanism for BGP. It's very very important. Okay, let's take example some BGP message, that is open, update, notification, and keep alive. Then, once you configure the BGP agency as well as neighborship, they will going to be set up, and you will get the message. Updates, if what is happening, if any changes is happening, that will be the update. If in case it is going to be down or error in BGP, you will get the BGP neighbor notification. And the keep live, in the sense the BGP session is active. If it is not active, then keep live session will or message you will get. So that is the four types of the message, and make sure you are open update notification and you are running this message and briefly way. Okay, the next feature is this metric in BGP is attributes. There are multiple BGP attributes, well known, optional, mandatory, next stop, path, origin, local. There are multiple attributes that helps for this complexities network, and it is totally defined. So that's what aggregator, communicator, and extender communicate is. So that means transitive as well as non-transitive. And we'll see into attributes into the next slide, upcoming multiple slide while doing the lab for this one. So that is the things. Now we'll focus on this BGP neighbors. BGP neighbors, how they are going to be TCP connection, or which port will be going to be TCP, that is TCP 179, to maintain the neighbor that I already mentioned. For in BGP, we need to be configure the manual routes, that is where we need to be mention neighbor command, and where the next hop count or where the neighbor, that information we need to be mentioned. If let's take example one more router we have added, then you can mention the two neighbor for this one. So that is BGP neighbors we are configuring as manually. And when it's called BGP pair or BGP speaker, that is very important things. When if BGP pair, if BGP pair is there, that is you can see the keep live message, that is BGP session is active. And there are two type for this BGP neighborship, that is internal BGP and external BGP. Internal BGP works as the same AS number, and external BGP will work as a multiple AS. So that is the internal as well as external. And in next slide, it is similar. BGP tables maintain the three tables, that is neighbor table as well as database table and IP routing table. Similar way, AHRP, OSPF, they are maintaining their table. But for neighbor, we need to be manual configuring for the all BGP neighbor. And you can mention, so IP BGP summary, you will get that all the details, which is the neighbor on. We'll see into the lab as well. And show IP BGP neighbors, that is you will get a neighborship as well. And show IP BGP, that is will be get the list of the all network known by BGP with their path, that is using of the path vector process, path vector mechanism. And show IP route will give the all the information. So and we'll see. Okay, I'll be explaining for this lab as well. But the configuration part is router BGP as well as what are the AS number you have, the network and mask you can use, and you can use neighbor and remote. What is the remote AS number that you can mention? So that is the overall of the BGP basic things. So let me, I already opened this path. Now let's take example R1 router, which neighbor? this one neighbor and this one neighbor. For this router, which one? This is the neighbor and this is the neighbor. For R3 is 2.2.1 and 3.3.2, that is neighbor. And for R4 that is 4.4.2 and 3.3.1. So let's move on. Configuration part. I have already created this topology. That means I already assigned the basic IP. And if I'm going to be here, show IP route, there is a nothing is there, right? Only directly connected network we can see. Now here we are using the AS500. So let's go on the router one and go to config terminal, router BGP. We need to be mentioned what is the S number 500 and give neighbor for R1. Which one neighbor? This is this port 1.1.2/8, and for this one 4.4.1. So I'll be going to be a neighbor 1.1.1.1.2 remote. Okay, let's question mark. The password is we don't want to be because this is very say authentication. We'll see into the next lab, but here it's remote AS. Similar way, neighbor. Which one we have? The next one is 4.4.1. Mention the same one. Remote AS 500. Okay. Now, if we need to mention the network, what are the network we have? Here for R1, I have 1.1.0/8 and 4.0.0/8. So network information also we need to be mentioned. Network 1.1.1 dot, sorry, 1 dot. Then let's question mark. What we need to mention? The mask. What is the mask for /8? 25.0.0.0 mask 25.0.0.0. Okay. Similar way network 4.0.0.0 mask 255.0.0.0. Okay. Now it's completed. If you want to change router ID, here 1.1.1 is there, right? 1.2 there. If you want to change, you can change it, but I don't want to change router. Don't I don't want to be changed right now. So I'll be checking here what command I can use for this one, default distance network, and you can see the and why I don't want to be those synchronization right now. Why it is I will explain in through the EJ when we'll configure the external BGP as well. So R1 we have completed. Let's move on to the R2. Similar way, router BGP 500. And what is the neighbor for this R2? 1.1.1 and 2.2.2. So mention the same things. What is the neighbor? 1.1.1 remote AS 500. Similar way, neighbor 2.2.2. You can see the status, the urgency. So that's what the message already started exchanging because we have configuring neighbor and you can see the neighbor is up and remote is 500. Okay. And Similar way, we need to be mention network for R to which network 1.1.0/8 and 2.2./8. That's it. And mention the same network 1.0.0.0 mask 25.0.0.0. Similar way, network 2.0.0.0 mask 25.0.0.0. Okay. Similar way, go to router 3. Similar command we can use router BGP 500 and then mention the for R3 which neighbor 2.2.1 and 3.3.2. Similar way we can use neighbor for 2.2.2.1 remote. Similar, yes, will be going to be used because we are doing this lab for the IGP only. Okay. Similar way, neighbor 3.3.3.2 remote is 500. Okay. Similar network, which network they are belongs to 2.0.0.0 mask 255.0.0.0. Similar way, network 3.0.0.0 mask 25.0.0.0. Okay. And last router. Oh, okay. We have configured the different router. Okay. Let me configure the network as well. Okay. Now let's move on to router 4. When it's come to router 4, which for 4.0, 4.4.2 and 3.3.1, let's make a similar command router BGP 500. Mention the neighbor which they have 3.3.1. The command is similar. Similar the network as well. And okay, now it's over. And how will be going to be cross verify? So let's move on to the our slide. The topology table which we have. Okay, show IPBGP summary. Let's come here. Now you can see neighborship is we have configured manually and what is the up and down time and how many hop count they have and which AS we are using. Similar way, we can cross verify. Now, okay, this by default we have a never active because we have configured R3 neighborship here, so it is showing never and which is already mentioned the neighborship, you can see the timing here. So if in case the interface is not connected to anywhere, so neighborship is not going to be maintained. That is the things and that is the concept. So similar way, you can cross verify neighbor as well. Okay, you can see the details, which is the neighbor or opens or something. Okay, what is the remote ID, which is the BGP neighborship, and the BGP states that is you can see established. That is the main here already we have done. Okay, lots of information you can see here, the overall configuration. Okay, let me stop it. And now the next what we are going to be cross verify as well as database table, show IP, show IP BGP. Okay, now you can see which network they have directly connected and which they are going to be used for this wait. What are the by default what is the there wait? I will show into the what is the width, what is the path into the external BGP, and you can see I that means we are using the which protocol? Interior Gateway Protocol. That means it is showing to I and we are using for the single autonomous. And if I'm going to be used show IP route, I will get all the details here. Okay. B that is means let's say here B is BGP and is C is the directly connected and B which via port they are going to be used and what are the their distance. So that is the overall for BGP. You can cross verify here as well. So okay. So you can see the neighborship as well as show IP route, and you can see the C is directly connected and which BGP they are using. So then you can add here your local network as well. If you can add switch or here you can add the you know what are the your port you can add it and but you where we need to do in changes go to router BGP and add the network as well the next. So let's take example. If you want to be add here router, if you are adding the one more router here, one more router here, one more router here, then only you need to be configure the neighborship as well as the what are the remote path. And similar way for this different if AS is there then you can configure, but the basic things or it is very simple topology where when it comes under the in one AS you have the multiple. What I'm saying, if in AS if you have the multiple router and multiple neighborship, then how will be going to handle and how will be going to communicate for the different AS. So we'll see into the next session, and before that we need to be create some rules, some state we need to be follow for this BGP. And one more, uh, man, I can tell you one of the okay, this is very useful for this cloud as well. When you are creating, let's take example, I have AWS and this is GCP, and if you want to be connect the site to site connectivity or AWS VPN connectivity, the BGP is very useful for the cloud perspective as well. So that is the overall concept of the BGP is theoretical and it is very easy, but we'll see what are the attributes in the path route summarization as well as manual and auto summary, and that is the basic features of the BGP. And we have seen the this lab of the IGP. In next session we'll move on this external BGP as well as what is the state of the BGP and how it is working and what are the attributes we need to be follow, what are the rules we need to create for the BGP. That's all for this one for this BGP session, but definitely we'll come up this Next, external, and the BGP when it's going to be cloud part, definitely then it is very very useful. That means if you have the what are the private subnet, what are the public server in AWS, and similar way you have configured the GCP. And let's take example, you have done the primary things, primary configuration, then secondary configuration is the BGP session. Once you establish the BGP session, then they are going to be uh, share the, or you can see the traffic. That's what it is, very useful protocol, and it is very very useful for the network security as well as cloud. So that is the overall concept of the BGP or basic as well as IGP. So if you are once we are moving to the external, then we can see, and if you know about the internal protocol, that is we can use, that is RIF, EIGRP, OSPF. That is I already created the this already configuration part. I haven't done for the IGRP because IGRP is advanced and it's all covered the IGRP. And what are the neighborship they are maintaining using the multicast address? That is already we have seen. What are the multicast address they are using OSPF, but BGP you should have configuring the neighborships to manually using the path vector protocol. And what is the path vector? While transferring to one router to another router to this router, they are maintaining what they are maintaining, the network, as well as what is the AS number and what is the network information they have. And let's take example, if you have the multiple ISP here and they are connected to each other, and if you know about, if you don't know or BGP don't know where is the located the Google server, then it is we can't acknowledge to users. So it is BGP must know where different AS number, different router, and where it's located the server. So that is the overall concept of the BGP. That is overview and IGP. Next session we'll talk about the external broader gateway protocol. Before that, we'll talk about the state. That okay. Thank you all. If you're getting some knowledge from this one, please like and subscribe my YouTube channel. Thank you so much.